same.
All right, so we good on number 19?
Yeah.
First derivative is 0, second derivative is negative, means relative maximum at that point. Both the first and the second derivatives are 0, means that you have a point of inflection at that point with a horizontal tangent. Okay? All right, are we just going?
Yeah.
Okay.
You don't have to. Just go.
You can skip 27 though, I got that.
All right.
Because Mary got it.
Because Mary got it. Mary got
I
it.
mean, I pretty much got 27 too, so.
Okay.
Evan and I both got it.
Then we're probably good. All
I
right.
Mary, don't
So-
say that. You got like every math question.
21. We have the derivative equaling 0 at 0, 2, and 4. So what's happening there?
No. Mary's like, okay.
What's happening
I
at...
did it on one of them.
Okay, hey,
Those are
3P.
Those are the. Wait, this is the
First
first derivative.
first derivative, so the critical
Maximums
point.
and
Okay,
minimums.
so it's a maximum or minimum, or it could be a snaky thing, okay? All right, do we have any points here? No, we don't. All right, so the derivative is greater than 0 between, if x is less than 0. So if the derivative is greater than 0 when x is less than 0, yeah, that means it's increasing. I'm just going to draw an increasing thing, we'll change it later, okay? And it's also greater than 0 from 2
It
to
helped
4.
me by doing a sign chart.
Do a sign chart? No.
I just did that thingy that you did that one day where you drew the maximum or minimum, like you drew a little thing where they
A
could
little
be.
thing there, okay? So maybe we should start, well, but we don't have any points here, so
Yeah,
that
you
makes it
don't have
hard.
lines.
But you don't
Okay,
need
so
it.
it's increasing over, here I'm going to do
You
this.
just make it wherever you want.
Sweet.
You're using the I.
Okay. So in this range right here, it is increasing. And in this range from 2 to 4, it is also increasing.
Is it also decreasing or increasing? I think it's increasing.
Increasing because the derivative is positive. And then the derivative is negative from 0 to 2. So we've got decreasing in here. And it's negative from 4 to forever. So it's decreasing there. Okay. Then the second derivative is greater than 0, which means it is concave up from 1 to 3. So in here it's concave up. So how do you, and it's
Kind of just have to draw it.
concave up, so I'm going to go like this, and then like that.
What?
Concave up from 1 to 3, you're okay with that? Okay, and then it is negative when it's less than 0, so that means it's concave down the whole rest of the way. And so I'm going to incorporate this little point here, so it's going to look something like that, right? So I've got increasing, I've got the derivative equals 0, I've got decreasing, I've got concave up, I've got increasing, so far so good. Where am I? From 1 to 3, so it's concave down, so I'm going to sort of tweak that just a little bit there. Make that like that. No, I missed
not
it.
quite.
Not quite. I gotta go to here.
Yeah, not.
There we go. That's good. Okay, so let's check and make sure I have all of the things
Why
I
did
need
you only
to.
go up one? Why couldn't you go up five?
I could go up a million if I wanted.
So the whole thing was shifted down.
Yeah, you're fine. Yeah, right.
Yeah,
So
mine
we
goes
don't,
down.
because they didn't give us any actual points on the graph, we don't know what level this is at, okay? So derivative is 0 right here, horizontal tangent at 2, horizontal tangent at 4. It's increasing, decreasing, increasing, decreasing, concave down, concave up, concave down. So I think we're okay. All right? Okay, so no 27, don't need it. E. Okay, oh yeah, one interval is increasing, decreasing, that's easy. All right, assuming that f of 0 says, oh, are you sure it's easy? Because this is the graph of the derivative, not the original graph.
Yeah.
Yeah, I just ignored that.
So
Everything about it was easy.
did you say that
Oh, wait,
it?
no, I did that.
You did it?
Increasing this constant.
Okay, yeah, it's increasing where the derivative is positive or above the x-axis. So it's increasing from 0 to 2, and from 4 to 6, and from 8 to infinity, right?
4 to 6. Why not 3 to 6?
Because it's not, this isn't the original graph. This isn't, the derivative is increasing from 3 to 6. This is the graph of the derivative.
Can you say it's 6 because it's those
So you make an open bracket there, okay? So the original graph is increasing anywhere the derivative is positive. So that's here to here, here to here, and here to here, okay? So 0 to 2, 4 to 6, and 8 to infinity, or 9, I don't know if you want to stop it, okay? Kua, you can't do that. You can't do that. What's she doing? She spends so much time on her phone in this class and then bombs the test. You making bad choices. Don't make bad choices. Okay, then decreasing is where the derivative is negative, where it's below the x-axis. Okay, so that would be from 2 to 4 and from 6 to 8, right?
Yeah.
Okay, so it might be good to, I like,
We should go through this one.
yeah, right. So I like the idea of making a sign chart, okay? So the zeros of the derivative are at 2,
4, 8.
4, and 8, okay? From 0 to 2, it's positive. From 2 to 4, it's negative. From 4 to 8. Oh, so we have a discontinuity at 6, right? So that counts as a critical point. So we need that in there too. Critical, where the derivative is undefined is also a critical point. So 4 to 6 is positive, 6 to 8 is negative, and 8 to infinity is positive, okay? So increasing, decreasing, increasing, decreasing, increasing. Does that make sense? Okay, so then where does the original graph have a local maximum or minimum? 2 is going to be a maximum because it's going from positive to negative. 4 is going to be a minimum. 6 will be a maximum. And it's going to be something weird there. It's going to be like a corner or a cusp or something like that, because the derivative is undefined at 6. And then 8 is a minimum. Okay, so let's do that. On what intervals is f concave up
So-
or?
Before we move on, is this at what values does x have? So if you have to put the point, like, you have to plug it back into the original.
No,
Okay,
we don't have an
know.
original function. Yeah, so when it says what values, they're asking for the x values. If it says what is the maximum or minimum, then you have to plug it back in. Okay. All right. On what intervals is f concave up or down? So that relates to the second derivative, right? So I'm going to add the zeros of the second derivative to my sign chart. Where will the second derivative be 0? At 3 right here, right? So that's going to be this thing right there. Where else will it be? Have a critical point right here. That's 6 because it's undefined right there. Okay? So the second derivative over here to the left of 3 will be, well, will it be positive or negative? Is the slope of this positive or negative? Negative, so this is going to be negative over here. Here the slope is positive, and where it's undefined, you have to be careful. That's a lot like the even roots. It can be the same on both sides of that. So if we look at 6, it's positive here, and it's positive here. Okay, that doesn't behave like a normal 0 does. So it's concave up from 3 to 6 and 6 to infinity. Say it.
Infinity.
And then concave down.
Negative infinity. And
Negative
below.
infinity to 3. Okay? All right, what are the x coordinates of the points of inflection? 3 and 6. No, not 6, sorry. Because it stays concave up and then concave up
It's
again,
just
so
a
just
three.
3. Right, just where it changes from being concave down to concave up. Assuming that f of 0 equals 0, sketch the graph of f. Are you kidding me?
Okay, Reese,
Okay.
okay.
What does that even mean?
That means sketch the graph.
No, but sketchy original graph.
Yeah.
Yeah.
I don't know, that should have given me a hint that I did the whole thing wrong, but it
Concave
didn't.
down only from 0 to
0 to 3, okay.
Oh,
So
because
they're,
there's no arrow.
right, they're doing that dumb thing where they're cutting off the graph, and the book is pretty inconsistent about that, so I'm okay with that. All right, so if we're going to sketch the graph,
Just clean it off or not.
yeah, it's concave down here and has a maximum at 2, so it's going to go like this, all right? And then it continues to be concave down until it gets to 3, so that's going to switch right there. And then it has a minimum at 4.
Is 3 a 0?
Nope, this isn't my x-axis, that's just my sine chart. What's that? And then what happens here, it's going to increase and stay concave up until it gets to this maximum. Right there.
This is where I got confused. It's
okay.
somehow so far drawn my graph right, but the entire way through the thing wrong.
Oh, perfect. And then now it's decreasing, but it's still concave up. And so remember, this is where the derivative is undefined, so it's going to have a weird thing like this. Yeah. And then I'm going to put my axes in like that and make that be 0.
Okay, I did my graph right, but I did everything else.
Yeah, me too. It was really late when I did this. It was after class.
I did this in school.
Which took forever, by the way.
The basketball game took forever. Called a lot of
Felt a
fouls.
lot though.
All right. So you guys thought 27 was easy.
Very.
Mary, what?
It was 2 in a row. One time Coach Galloway
Self-important,
chased the
Mary.
ref. That was funny to try to get attention.
I got it right, so we
That
have
was
to
an
go
idiot.
over it.
Well, actually,
Okay.
I did it wrong.
The guy on the left, on the.
No, the guy that.
Okay, number 32. What are we going to do? Take the derivative.
Put it out, take it out.
Okay. So derivative of 200 is 0. What's this?
I don't know, but please do the
order.
4, the x to the 4.
I didn't realize.
4x cubed.
I already read that.
Okay, so if you have OCD and you need to write your polynomials in standard form, then you're going to want to flip that around like that. All right. What do you do now?
You factor out 4x and set equal to 0.
Factor out 4x
squared.
squared.
And set equal to 0.
And then that leaves me x plus 6, and I want to set that equal to 0.
And then you have the Mr. P situation.
Right? Okay, good. So we have, since it's 4x squared, that means that this is going to be a multiplicity 2.
Oh, I didn't think about that. Now
And
I
then
feel
this is
stupid.
going to be negative 6. Now you feel stupid? Oh, sorry.
I thought I did this all right.
Dang it. Okay, now what?
Sign.
Put in 1. What'd you get when you put in 1, Taylor? Positive. So it's going to be positive. Whoops, I won't do that on the bottom for the first derivative. Positive here, positive there, and negative there.
You're getting pretty good at those signs.
So now you know the intervals of increase or decrease, right? Yeah.
I don't understand. I can say it's like negative. Like I understand why the sign chart should be like positive, positive, negative, but when you plug in like negative, bigger negative numbers, you still got a positive.
So you're going way negative on me here?
Yeah,
And
like
you're getting a positive answer?
yeah, like if I put
I
a
disagree, sir.
If I put a negative, yeah. If I put a negative 11,
Uh-huh.
I got a positive.
Then you're putting something in there wrong, because negative 11 squared is positive 121.
Oh, you're supposed to put back. I thought you were supposed to put back to the red.
Oh, there we go, good talk. Yeah, when you're trying to find the increasing, decreasing, you put it into the derivative. Okay, glad we straightened that out. Yeah, that's really important. Okay, so we know the increasing and decreasing. We also know the local maximum and minimum values. What's negative 6? Oh, we don't know the values. We know where they occur.
Is maximum
Okay,
Wait.
this is a, sorry, minimum.
Yeah. And zeros. And that's just a double red. Zero's not
Increasing.
nothing.
Right, and then this
Oh,
is
yeah.
increasing levels out, it increases again, so we got nothing there. So we know -6 is a minimum, but this says find the local maximum and minimum value. So now I need to take that and plug it into,
Wait.
hold on just a second, let me finish my sentence. Now I need to take that and plug it into Jefferson, the original equation to find the minimum value. You got what?
Someone
Negative.
should check that.
I would just like to
That's what I
point
got
out
too, right?
that you're doing like the opposite of what you supposed to do. This one said values also.
We
That way
did?
it said values. So why can't we?
But
This-
we didn't even.
At what values of X?
So why do you have to do both?
This one says find the local maximum and minimum value.
And also.
So one of them is saying, who
No, that's
is the
stupid.
tallest person in this class? And the other one is saying, how tall is that person?
Who is
Okay.
the tallest, Evan?
We'll go with Evan, yeah. Okay, you want someone to confirm your,
Yeah, I got the same
okay, what was it, negative what? Negative 232, okay? And again, there is no maximum. All right, so now we're going to do the concavity and the inflection points, and so that is the second derivative. So if I take the derivative of this, I get 48x plus 12x squared. Okay, 12x squared plus 48x is the
Are you gonna
second
miss
derivative.
us?
Am I gonna what? Do you want to know the truth?
It's in misplaced scum.
Do you want to know the truth? Okay. Oh, no. Do you know how many students I've taught over 20 years?
I wonder how many people probably ask that question.
Every senior class, every single one. Right.
Also,
Didn't-
last
yeah.
day of the semester, we try studying again.
No.
Yeah.
That's not true.
No, on the last day of the semester, you'll be panicky trying to finish the test that you started the day before.
What? No. It's not on the board.
It's on the
Okay,
border, it's not official.
so if I set this equal to 0, what are my two values for x? That'll
4 and
make
0.
that
Zero and negative 4.
Negative 4 and 0. So I'm going to put those on the top here to distinguish.
This is where it got bad for me because I had to keep
This
switching
is
back and
where-
forth because I was at the bottom of the paper.
Oh, okay.
And because
Okay, so we need to pick a number again.
1. Negative
1. And if you plug 1 into the second derivative, you get positive. So that means this is going to be positive, negative, and positive. So concave up, concave down, concave up. Okay, and then it says find the inflection points. So we have only found the x coordinates of those inflection points. We need to take those and plug them back into the original equation to find the y coordinates. I'll do 0. You
I'll do
negative
0.
4. So this inflection point
I have
is
negative
0
56.
to 100, and the other one is negative 4, negative 56. Okay. All right, so then it wants us to graph this, and if we're going to graph it correctly, since we do have some points, we'd have to put this way up at 0 to 100, and we'd have to put this way down at negative 6,
No,
negative
no.
232.
Yeah, you just kinda
Not
just
doing
sketch
it, yeah, so we're just going to do a rough sketch. So this has a minimum right here, and it's concave up. Then it is increasing starting right there, and it changes right here to be concave down. Things level out right there, so there's no max or minimum, but the concavity does change, so it looks something like this. And again, this point would be way down there. Negative 4 would be partway up with it, so this is a really stretchy parabola kind of thing, and then this point would be
Yeah, and
way
I
up.
tried to graph it, and
Yeah,
it was just like a line.
right,
on
you
the
can't, yeah,
top.
can't even see, okay, I mean, change your window and all that, but
Oh, too easy.
whatevs, okay.
This is where I got 41.
All right, suppose the derivative of function f is that, on what interval is f increasing? So now we just need to think about like some basic algebra here. What are the zeros going to be?
And negative 1 and
-1, and that's a double root, good, because it's squared. Also 3, and that's a
But it doesn't matter
quintuple
because
root,
it's
but it
odd.
doesn't matter because it's odd.
And then quad root.
And then 6, and that's has a multiplicity of 4.
And I say quad root.
You can say whatever you
Whatever
want.
you want.
All right, so pick a number.
1.
0.
0, thank you. I'm not going to figure out exactly what each one of these are. I'm just going to figure out the sign of the answer. So if I plug 0 into here, well, it'll be positive. If I plug 0 into here, 0 minus 3 is negative. A negative number to an odd power will still be negative, so that's going to be negative. And then if I plug 0 into here, negative, but to an even power is positive. And so
Yeah,
that's
it
going to end
doesn't
up
matter.
being-
Once you have that negative in there, it has, oh wait, no.
all right, so that means this is negative.
Because it's
No, because we plugged in 0, we got a negative
And
answer.
then the one to the left.
Yeah.
Okay,
Negative on the other side.
hold on, we're still counting it. We plugged in 0 and we into the derivative and we got a negative.
So why do you have 3 on
What? No, because this, if I plug 0 into here, it came out to be positive. 0 in here is negative. I just want to figure out what -6 to the 4th actually is. I just need to know the sign of that. And then the positive times the negative times the positive is what negative.
Okay.
I got it.
You just like randomly put
Okay, so if this is negative, then this is negative because it's an even root. If this is negative, then this is positive because that's an odd root, and this is positive also. So on what intervals is it increasing?
I just left that as my answer.
Okay, that's fine. Yeah, technically you're supposed to say 3 to 6 and 6 to infinity because that's 6. It's going to level out and it's not increasing right at that point. So something like that. Okay,
Oh, I need help on 48.
use a graph of f to estimate the maximum and minimum values, then find the exact values. So we're using a graph.
So I'm totally
You
used
just use the, yeah, you estimate.
Okay.
I
In
put
physics?
5 over 6 and 5.
Are we just graphing this like on a
No,
calculator?
and then you have to figure it out.
Yeah, it says use the graph to estimate.
Do you not read the problem?
Okay, so can I make this be the graph that I'm going to use? Excellent. Okay, what is it? X plus what? 2 cosine x. And I want to only go from 0 to 2 pi. And I don't need this to be something. So I'm going to go negative 5 to. All right, so I would estimate that they happen at, I have no idea. I got to change my window to see where that top part is. And I'm going to go by what for my x's, like pi over 2 maybe? Pi over 4, pi over 6? Pi over 4, be a little bit more accurate. All right, so this is a maximum that's at about what?
Put pi over 6.
5 or 6, yeah, I like that, because 5 or 8 will be right in the middle, but it doesn't seem like it's quite that much. So I'm going to have a maximum maybe at pi over 6. Okay, good guess then. And then let's see, pi over 4, pi over 2, 3 pi
How am I pi
over
over
4.
3?
So what's that, maybe 5
5 pi over 6?
Right, that's the answer.
Okay, so then I'm going to estimate
So
a
good
minimum
explanation.
at 5 pi over 6, and then I don't know if this one is included or not.
It's not, you don't know.
We're also going to have a maximum at the endpoint of 2 pi. Okay, so now I need to find the exact values. How do I do that?
You take the derivative.
It's the derivative, so that's 1 minus 2 sine of x, set that equal to 0, solve it. Oh, what do you know? You get 5 over 6
Sine
and
x
5 over
equals
6.
what?
That gives you
Sine
sine of x has to equal
Yeah.
1/2, and that happens at pi over 6 and 5 pi over 6.
But can you show that with the triangle?
Show why that happens that way.
I'm not good at the triangles.
Nobody's good at the triangles.
No, I used to.
You're good at the triangles?
Connor's good at the
Yeah?
triangles.
Okay.
We're gonna pose this yesterday on the triangle.
Okay, so we want the sine of x to equal 1/2, right? Okay, so weigh in any time if you have a better way of explaining this. So sine is opposite over hypotenuse, right?
Especially here.
Okay, so the opposite in my little triangle has to be positive. So that means it's going to be right here, and it's going to be right here. Okay, so this is positive 1, and this is positive 1, and this is 2, and that's 2, which means that's, okay? And so now you know that you have to have a 30, 60, 90 triangle, right? You know that this one is the short leg, so the smaller angle is going to be across from the short leg, so that's 30, but in radian speak, that is pi over 6.
Oh, okay.
Okay, this is also going to be pi over 6, but we don't care about that. We always want the positive angle, or the angle from the positive x-axis, and so that's going to be pi minus pi over 6, right? Which is pi over 6. So those are our two answers. Okay, estimate the value of x at which f increases most rapidly. So if we go back to this graph again, where does it look like it's increasing the most?
Like that.
Tell me when. Yeah, right in here at the point of inflection. Okay? That's what the point of inflection gives us, is where the increase is the sharpest. And so go ahead, Miss Estimator. What's that point of inflection going to be?
What are you going by for?
Pi over 4, so yeah, pressure's on.
No,
Come
you guys
on.
can't do that.
We just did, that just happened.
No, let me do it.
1/2 pi, whatever that is.
3 pi over 2.
Yeah, it seems like about 3 pi over 2 is a good guess. All right, so to find that exactly, what do? Take the double derivative. The derivative of this is,
We just got warm in here.
I know, that he just kicked on, huh? -2 cosine of x. If I set that equal to 0, I need to know where cosine of x equals 0. Where's that, you say? Well, all you have to do is know your good dance moves, and then you'll have the graphs memorized.
Oh, Mr. help me on that.
Okay, now I can take it down. So the cosine graph starts here and then goes down and then back up. So it's going to equal, no, that's not even right. That's a bad dance move. That's a negative cosine. So the cosine, yeah, oh, on the very
Yeah, it
left.
starts like
Oh,
this and
okay. So you're thinking the cosine graph starts right here?
Yeah.
Okay, so it equals 0 at pi over 2 and 3 pi over 2. Okay, so good, yes.
I like the 1 over
I
x.
did it yesterday.
That's your favorite dance, Mary?
The 1 over
The 1 over x?
Maybe the trap one.
I like that.
Right here.
That's pretty cool.
Okay, so 3 pi over 2 is a winner. All right?
I was going to say 6 pi over 4, but then I was like...
We would have accepted that. Yeah, we would have accepted that. All right, this is a really dumb one. Let K of T be a measure of the knowledge you gain by studying for a test for T hours. Which do you think is larger, K of 8 minus K of 7, or K of 3 minus K over 2? So, in other words, do you think you learn more studying in between the 2nd and 3rd hours, or the 7th and 8th?
Second and third.
Right, the 2nd and 8th. So this one is going to be larger.
8 hours.
Yeah.
Is the graph of K concave up or concave down? So does your knowledge go like this?
No.
Or does your knowledge go like this?
And then just
Okay, so that means it's going to be, yeah, this flattens out. Actually, it usually goes like this.
And then plateaus at the end. and just
Yeah,
like
right. Down in the negatives.
Before the test.
This magic thing. Okay, so that would be concave down. That is silly. Okay, coffee is being poured into the mug shown in the figure at a constant rate.
Imagine the Keurig, because we just got one for Christmas. So
I know,
The what?
Keurig.
word you're saying.
Here,
That's
that's a
an
brand
instant
name.
coffee thing with a little.
I don't drink coffee. All right, sketch a rough graph of the depth of the coffee in the mug as a function of time. And so what is going to happen as you start filling it up? It's going to fill up
Really fast?
really
Really
fast.
slow and then really fast.
Right, it's going to be slow and then it's going to go really, really fast.
Well, yeah, well, I mean, like, that's what
Okay, slow down again.
That's a
So-
weird.
Only because the shape of the cup is weird.
Right, exactly. But that's what they're trying to do. They're trying to make a little.
Oh, I
So
thought
this
it was
is
for all
the inflection
cups.
point. No, no, no. Right there. If it was a regular cylindrical cup, it would just be a boring linear cup.
Inflection point, the cup is half full.
Okay? So there you go. The significance of the inflection point is that happens right where the cup is
It's actually all
narrow.
full.
All right, next one. Assume that all the functions are twice differentiable and the second derivatives are never zero. Okay, if f and g are concave up on I, show that f plus g is concave up on I.
Yeah, this is where I was like, I will do that.
What?
After 4 hours.
Okay, so we're going to graph a little function f that's concave up over that interval, and then we're going to graph another function g that is also concave up. But I already screwed up.
What do I do?
Oh, no, we're okay. I thought, because it says the second derivative is never zero, so there's no point of inflection. I'm wrong. Okay, so if you add those together, what is it going to look like? Super, yeah. Right. So if I take this y value plus this y value, it's going to be way up here. These two y values added together are going to be a little bit smaller because both of these are smaller than what I originally added. This is going to be the smallest y value of them all, and then it's going to go up from there. So the sum of those functions is also going to be concave up. Okay? All right, if f is positive and concave upward on I, show that the function g of x equals f of x squared is also concave up on I. So now all we need is that top function. So f is positive, it means it's above the x-axis the entire time, and it's concave up. Okay, so now I'm going to take all of these values and I am going to square them. So the same thing is going to happen,
They're all
right?
positive.
This is going to be way, yeah, they're all positive, and that's why I said it had to be positive, because if we had a negative one, if it went below the x-axis, that would kind of screw this game up a little bit. This thing squared is going to be a really big number. This squared is going to be a big number, but not as big, right? And then this is going to be, yeah, so it's also going to be like that. All right? It's not stupid.
Yeah.
All right, 62. For what values of c does the polynomial blah, 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 blah have two inflection points, one, none, and so forth? So what do we got to do? Take the derivative. So 4x to the third plus 3cx squared plus 2x is my first derivative. Yep.
If I don't see it.
Yeah, but they're asking us about inflection points. So I need to take the second derivative.
One more time.
12x squared plus 6cx plus 2. Okay? And so I would like that to have two solutions when I set it equal to 0. What a great algebra connection. What kind of a beast do I have here? A quadratic. How do you tell how many solutions a quadratic has? No.
Nope.
No? Don't remember? The discriminant? B squared minus 4ac, because it's underneath the square root. What has to be true about this for it to have two solutions? It has to be greater than 0. So that, in this case, b is 6c. So bless you, b squared is 36c squared minus 4 times 12 times 2. So if we want 36c squared minus, what is that, 4896? So if that's positive, then there'll be two solutions. No, but what would be the restrictions on C for that to be
Greater
positive?
than 3.
Greater than 3 is 96 divided by 36, 3? I don't think so.
I did 96 divided by 32.
So C squared has to be greater than 96 over 36, and then I need to take the square root of that. I have to take the square root of it first, though. Square root of 36 is 6. Is there something fun that goes into 96 evenly besides 4? How many times?
16.
16 is better, 16 times
Oh,
6?
wait, yeah, it is.
Okay, so that, oh, perfect. So that would be 4 root 6. In other words, if C is greater than 2 root 6 over 3, then you will have 2 inflection points.
How is that for?
How would you have, I thought the 6's were going to cancel, but it's going to be the square root 6.
Yeah.
How would you have 1 inflection point? What would that have to equal?
An I number.
Nope.
Positive.
Nope.
The number.
It already is positive.
Number.
Nope. What does the discriminant have to equal for it to have?
0.
Negative.
0, right. So that means this would be equal to 0, which means if C equals 2 root 6 over 3, then you will have 1 point of inflection. This is greater than 0, so this would be the case where you have 2 points of inflection. Okay, what would the value have to be by for you to have no points of inflection? So it would have no solutions. It would have to be negative. So if C is less than that, then that means the stuff underneath the square root will be negative, and that means you will have 0 points of inflection. And what do you always say when they tell you to graph it? Okay. Illustrate by graphing key for several values of C.
Wait, why did you write
Because, I don't know, I must have figured out something.
four?
Oh, I didn't
You
simplify,
just
I
wrote
just
the
did it
unsimplified.
simple.
I was confused.
That is a confusing thing for me to do. I looked at the wrong one. Okay? Are you going to make it? No, 100% for sure. Okay, show that the function g of x equals x times the absolute value of x has an inflection point at 0, 0, but the second derivative of 0 does not exist. You just what?
Graph on your calculator.
Yeah?
See what it-
Okay. I don't know. That seems kind of like cheating.
Well,
Yeah.
it ain't cheating, ain't
So,
True that. You ain't cheating.
okay.
That's the like model.
Okay, so there's the graph of x times the absolute value of x. Do you see that inflection point? What? That's 0. Why would the
That's what
second
it said.
derivative not exist? Yeah, right. So but that's the first thing. It says show that it has an inflection point of 0, 0. How do we know that? Huh? No, I think if we zoom in, I'm guessing if we zoom into that spot, there's more going on there than you know. Does it tweak out a little bit? No, I don't know. Why would the second derivative not
I
exist?
just think that maybe it's like horizontal or
One more. Give us a tell.
Those are the horizontal tangent, right? That's why the.
All right, so we're done with that.